Welcome again, everyone. On this lesson for today, we'll be speaking about sets. So Python also includes something we call sets, which is also sharing the DNA with list and tuples, but there are some few differences that we'll get to see on sets. So sets, the same with tuple and list, are used to store different different items in a single variable, and then it is one of the built-in data types that are used in Python to store a collection of data, right? We've already talked about a list, we've already talked about a tuple. There is the fourth one, which is called a dictionary, which we'll speak about in our other topic. So let's just get ahead with the sets, but we must just remember that a set is a collection which is both unordered and unindexed, so meaning that we are not going to be able to use indexes in order for us to navigate on a set, just as we've seen on other lists and tuples, where we were able to use index like zeros and 1 to locate a certain item. Okay, so let's just start with our lesson on sets. So I'm just going to create a simple set here, and I'm going to call it my set, and then you will also see that a set is now identified with curly braces, right? And then we can now list items in our set, and we're going to start with an apple, and we're going to go ahead and list a banana, and then we'll list cherry. So we now have 3 items within our set, right? And then we can go and print this particular set to find out what are the values in this set. Does it cover what we talked about? So there we go. You can see we have all of our items which are found in the set. Something to notice here is that it is printing these values in a descending order. If you're able to see, you can see apple becomes the last value in the set, and then banana is still in the middle. But then maybe to make you understand, let's put one more item here and say berries. I'm not sure if this is the spelling, but let's just go ahead with this one, or mango. Let's hit mango here, see what happens. So you can see that our set is printing now from apple, banana, cherry, and mango, right? So all of our values which are found within our set, we are able to get them around. So the other thing is that since it's unordered, right, this output can come up in any other different way, right? It won't forever be in this manner. As you can see now, when I run it, mango becomes the first one, banana is still in the same position, apple is in a different position, and cherry is in a different position. So each time you run it, it's unordered, so it picks randomly which one must come first, right? So if you continue running it, the set can change as it wishes, right? There is no particular order that is going to come out with. It's just random order that will keep popping up as you run this. Okay, so the other things is that in a set, it's going to be very unique, because we have not seen this in a list, we have not seen this in a tuple, but in a set, duplicates are going to be ignored. So let's say we decided to duplicate banana. So we decide to say we're going to have 2 bananas. When we run this, you will see that we'll still get just 4 values, because banana is duplicating, right? So we're not going to get 5 values, because it searches if ever there's any similarities within our values. But let's check, is it case sensitive in terms of duplication? Yes, it is case sensitive. So if you write a banana, the other one with the uppercase B, the other one with the lowercase b, it will regard those as different bananas. So but then if you want it to also work on duplicates, you must make sure that both the items are spelled exactly the same, so it's not going to repeat those items. The other thing you might want to do is the famous length that we've been talking about. So you can go find out the length of this set to find out how big exactly is this set. So initially this set is sitting at 4, so even if we remove banana, because this was an additional, and we run this, it will still remain on 4 because that was in duplication. So it does not focus, it removes all duplication. Okay, so a set does allow all data types, just like any other thing. So you can see the data type we're working with here is currently on strings. So I can have I can call this set fruits set, and then I can have another one called number sets, right? And then this one will just contain numbers, right? So it will contain any other number that we wish to have there. There we go, that will be the set for numbers. You can have you know, boolean, you can have any other number, but for now this is fine. You have seen other examples that you can try out with when we're working with lists and tuples. Okay, so the last one we'll focus on this introduction on this lesson is the mixed data type. So I'll just say mixed set. So on mixed set, it does allow you, just like list and tuple, to get different data sets. So I can have a data set which contain you know, list of things like, okay, Monday, you know, 25th, 9,99. These are all different kind of data types that can be used, right? It's very important to notice that this also works. So if I go and say show me the mixed set, it should give me that result. But remember, the order is not important. Remember, it's unordered, right? So it's unordered and indexed. Okay, so you must just remember that. And you can also go find out if ever a certain something is also a what, a set. Let's say you were not sure whether number sets are actually a set, so you can go test, is this a set, is this a list, is this something, by just saying show me the type of the variable I'm seeing, which is called number sets, right? So if it's a set, it must tell you it's coming from the class set. So there we go, it is definitely coming from the class set. It's very important to note that. So if it's not a set, it will not tell you that it's coming from a class set. Okay, so that is the small introduction, and for now let's go and see how can you then access you know, values which are inside a set. Okay, so for you to be able to access values which are inside a set, it's very simple as well. Sometimes we normally use loops to run around this, but we have not done loops, so I'm not gonna touch that yet. I'm just gonna use a simple one just for accessing a certain set. So I can go and say print for me if ever you find let's say mango, right, in a set called fruit set, right? So I'm saying go find out if there's mango in fruit set, and let's see what will be the result. The result will be true because we do have mango in fruit set. So if I say find for me if ever we have a fruit on the list called you know, there are so many fruits. Let's say we're looking for a berry. So we're looking for a berry inside there. It will tell us it's false. We don't have a particular berry. So that's how we can access, right, if ever we have something. So you can think of an example as if you are looking for a student in a set of student. You are looking for a certain student, so that you are able to pull to check if ever they are there. You can easily use sets and use this functionality for finding out if something exists or not. Okay, so the other example will be, let's try to find out if we have a day called Sunday within our set called mixed set. So if I say from mixed set, find out do we have a set or a value called Sunday to tell us it's false. But then if I change the value and I say I'm looking for Monday, it will definitely tell me it's true. We do have Monday on that set. So it's very important. The other thing to notice is that once you create a set, right, you cannot change its items, right? But you can add new items, and that's where we're headed now. But you cannot go and say, Ish, I want to replace apple, I want to replace banana, because remember, a set does not have indexing, so you can't index pinpoint to a certain thing. Wherever you find Monday, it will remain Monday until the program ends executing. Okay, so next up, let's now talk about how can we add new items on a set, right? It's very simple as well. We normally use the keyword, which is very famous. So let's say we have a new item we want to add in our fruit set, right? So if we have a new item we want to add in our fruit set, it's going to be very simple for us to add it. We will just call the keyword to add a new item. Okay, so let's just go ahead and start adding. So let's say we want to add any other fruit. Let's add a watermelon or an orange. So we don't have an orange here. So what are we going to do in that case? We are now going to say the name of the set, which is fruit set, and we're gonna hit dot, and we're going to say add. So we're gonna call the functionality to add, and we must mention what are we adding. So I'm deciding to add orange. Okay, and then let's go and reveal the results if orange will be added. So I'm gonna say print, and I'm gonna call my fruit set there, hit the run button. There we go. So orange has been added, right, within our list, within our set, and it's now part of our set. Okay, the other thing we can do is we can actually have two sets and we combine them together by using a function called update. So let's say we had two sets. So let's say we had fruits and we also had meat set, and then on meat set, in fact let's call it animal set, and then we're just gonna have everything here. We're gonna have cattle, we're gonna have a dog, we're gonna have a cat, and then now we can actually go and this, remember now these are two different sets, right? So what I want to do now is to combine the two sets and see what happens. So I can actually say from my fruit set I want it to be updated using another set called animal set, and let's go see what will be my new set. You can see my new set now includes the sets values of animal set and the set values of what, of the fruit set. So it has added a new set into the latest set that I updated, right? So the other one is that we are also able to update the set using a list. So let's say this was not a set, let's say this was animal list. So let's assume this was an animal list, and a list we know it's covered with square brackets, right? So we can easily go and say, okay, update this using animal list and see if ever we'll get something. We still get very desirable results that we can use, right? So let's go ahead now and see what can we do to actually remove an item in the list. Because remember I said to update, as once you have apple in the list, you cannot go and change apple and say I'm replacing apple with banana, because it's not using index, right? It uses built-in functions. So now that means if now you want to remove a certain thing within your set, this is what you're going to do. So say you want to remove cherry. So what you will do, you will call the set itself, which is fruit set, and you will hit dot and you call the function to remove, and you are going to mention what are you planning on removing. So you are planning on removing cherry, and then let's see if cherry will be removed from the list. There we go. Cherry is no longer part of the set that we have created, right? So so if this the item itself we're trying to remove is not part of what we're talking. Let's say you are looking for watermelon, right? And watermelon is not part of this. What do you get? You now get an error because watermelon was not found in that list, in that set that you are trying to remove watermelon from. So you only remove something you are very sure it's within the set. Okay. So there is also the discard method. Discard also removes the item that you are looking for. So let's say you don't want to remove, but you say dot discard and you remain with cherry. Let's see what happens. It also performs the same functionality of removing, right? It removes the word or the from the set. It removes a value called cherry, and you are left with apple, banana, and mango, right? This is also very simple. The other one we can use is what you call the pop, right? So the pop method also works in the same manner. Just remove discount here and you put pop, right? And let's see if pop will also give us the same results. So with the pop, you must actually pop it while you are saving it somewhere else, right? So that we are able to see whether you actually popped it out. So what we'll do, we'll introduce a variable called removed item. So removed item from that set will be equal to this, and we can go look at it. What was that? What is the results of removing that item? Let's go see. That we don't even have to mention when we pop. We don't mention the position of where we're popping. So there we go. So when we say pop, removed item becomes cherry, right? But then remember, pop means that we are removing the very last item, and since this is an ordered set, you don't know when you say pop which item will be removed. So you will see here, if I continue running, it won't forever be cherry, it can be anything else. You can see now it's popping out mango, now it's popping out banana, now it's back to cherry, now it's mango, now it's apple. That's because a set is an unordered, it's unordered, meaning that when it's running, when the program is running, it place these things randomly. They don't go as you see them here, to say the first one is banana, apple, second one is banana, cherry, then mango, right? So when I say pop, I'm actually guessing what must be popped, and then it will show me what is it that I'm removing. If I'm happy, then I can say yes, indeed, perform that pop, and let's see the new set. So I will go and say show me the new set after popping any item that it wanted to pop. So I'll go and say show me now the fruit set. There we go. So now it popped up banana, and the new set now looks like this: cherry, apple, and mango. Remember, the odd is not ordered, so it's just gonna list them as it wishes. Okay. There is also a clear which you can use to clear all the items within a set, right? It's very important. You can clear to so you can say fruit set dot clear, and then dot clear will make sure that your set is now empty. As you can see, there is nothing on the set. There is also delete, and delete, make sure that you delete the whole set, and the variable name itself will no longer exist. So delete is very simple. You just go and start with the word del, and then you can see now even the colors of this one tells you it's no longer referencing to anything. It has not been declared, because it was declared here, used here, meaning it was removed from Python, and here you're trying to access it. So this will actually throw you a particular error to say fruit set is not yet defined. Okay, let's move now to joining sets, but we have seen this before on joining sets, so we should be able to do it when we do loops later on. So yeah, basically that will be the lesson on sets. It's a very important lesson to remember, but the major difference that we found here on sets is that once you create a set, it's more similar to a list, it's more similar to a tuple. The only difference that it has with a list is that with a list you can access them using index, like 0, 1, 2, like that. Here on set you cannot use that, and the other thing is that a list you can easily go and update any item on that list, right? But then with a set you are not going to be allowed to do that, because a set, once you create an item, you have created it. The only thing you can do is either remove it. You can also update the set by adding more values into it, and also clear the set and remove other items on the set as well. Okay, so there are more methods that you should learn on set that we're not going to touch. Methods like difference update, insertion update, is upper set, it's subset, all of those things. You should be able to learn them on your own. Okay, thank you for attending the session. I shall see you in the next session.